right. Quick question, logistics. Do we know what status of the speaker?
I'm not sure.
Yeah, okay, all right. We'll go ahead and get started.
I took the camera. Did you switch it back a little bit?
So,
To make sure. Center you.
Didn't know if they were running behind or not.
yeah, no, if they walk in, that's fine. Like I said, everything here is going to be available on the YouTube channel. So, you know, it's more or less a virtual audience as well as you guys here physically. So, it's great to be here. It's my pleasure to introduce the next speaker, which is me.
I can't wait to see how you.
Yeah. Well, you know,
I can come up there and do it.
I didn't think about this too much in the future, so let me go to the end where I had just a little blurb. But I'll just talk a little for a moment about my background. So I come from a computer science background, undergrad, computer information systems, and cybersecurity is my doctorate right here at Capital Tech University, 2019. So I'm a big fan of the program here, and I know the impact it's having in our community. I'm also a retired Air Force cyberspace operator. Early in my career, that title didn't exist. It was Communications Computer System Officer. But with that background, I navigated into the cyberspace operations realm, where I focused on cyber warfare. Ultimately, getting assigned to strategic commands, joint functional component command for network warfare, and assigned to the team to help build up U.S. Cyber Command. So 2009, 2010, I was the interim job director, Joint Operations Center director, as that was standing up. So it's really interesting time to see the offensive, defensive capabilities of DoD come together in order to make an operational impact. And yes, as one of our earlier speakers noted, we do not have a cyber service, so we do not have the benefit of a single organized, training, equipped entity, but we did have a lot of participation and contributions from all the different services that had cyber capabilities, notably the Army and Air Force, but also the Navy, Marines, and Coast Guard, and they're all contributing to that value today. I'm also at L3Harris. I'm a chief technologist for cyber operations, working in the Space and Airborne Systems segment. So that gives me a broad view of a lot of the capabilities we have in our company, some of which relate to what I'm talking about today. And then finally, as I said, my background is primarily offensive in nature, offensive cybersecurity. It may be offensive to some people as well, but mostly focused on OCO. And so taking that background and expertise and applying it into protecting smaller platforms and providing capabilities to our customers that can help them keep their products secure. All right, so back to my slides. So a lot of people are familiar with stealth technology. It's been around for a while. We have stealth capabilities built into all our major platforms. Of course, going back to aircraft, F-22, F-35, very capable. Our adversaries are also building, new stealth capable aircraft. We're seeing that as well in other domains with stealthy ships, tanks, vehicles, land vehicles, and now we're also starting to see that technology get applied to space. And so the question really at hand is, can you really make computer infrastructure stealthy? It's a big funky box. So we're going to talk about that today, and we're going to talk about that in the context of observability and of movement or maneuver. So when we talk about observability, what I'm saying is an adversary or enemy observing your actions in order to target you or to have an effect in their favor. And so in the aircraft scenario, because I'm former Air Force, what we talk about is the ability to stay unobserved as long as possible in order to achieve an effect. In this case, the aircraft on the left side here are friendly. They're engaging this Russian fighter, and the objective is to stay unobserved for as long a period of time as possible so that the target does not have time to respond. We can see that in the earlier generations of fighter aircraft, the distance that they can be detected, given the technology on board that Russian fighter, are in the hundreds of kilometers, whereas in our newer fighter aircraft, that drops down to below 50 kilometers. So that gives us a big advantage in time because the period from detection to action is greatly reduced. And on the other hand, if you're in a defensive position, you want to leverage stealth technology to remain undetected as long as possible, because that reduces your vulnerability and it reduces the ability to target you from an offensive standpoint. So stealth can be used in multiple ways. Now, when we talk about stealth, there are also some dependencies we need to think about. And with this in mind, with the concept of cyber warfare in mind, we look at what is it that's being observed. Sometimes detecting something or observing something can give away information that you're trying to protect. And sometimes seeing something doesn't necessarily give away that information, but if detected or if observed with a high enough resolution sensor, then you give away information. So, for instance, if you're looking for malware and you have a file hash, a cryptographic hash that identifies a file that is malware, you can detect that very easily. Whereas if you were looking for other traits within the file, you might not be able to detect them. The second thing to think about is sophistication of the observing technology. So in the radar scenario, what this means is you have advanced radar that can tell you flight characteristics of an object that's been identified, or you just have facta and maybe directional information. And the level of information that your sensor can provide will contribute to the protections that you'll be afforded. And of course, again, thinking through this offensively and defensively. Offensively, you want to understand as much as you can about the target so that you can fix on them and achieve your objective. And defensively, you want to try to keep that information as close to you as possible. Then knowing where and when to look plays into this as well. In the cyber domain, communications and activities can happen across a lot of different platforms in a lot of different modes. So it would be like finding a needle in a haystack. You can't necessarily depend on what is the phrase? Security through obscurity. But in a large field, it's difficult to acquire a target unless you know something about where that target's going to be. And then lastly, you need to understand your detection mechanism so that you can properly interpret what it is you're seeing at the time of detection. If you have, in the cyber defense arena, you have signatures that will alert on a certain pattern match. Just because that alert is given does not necessarily indicate presence of a malign influence or malware. You need to understand what's the confidence level of that alert. And of course, you need to try to maximize high confidence alerts and detection so that you don't get overloaded. Now, when you consider taking information and acting on it, we have to talk about Hoodaloo. Again, retired Air Force. John Boyd, as a fighter pilot, developed the concept of the Hoodaloo in order to strategize about combat operations. And it's a 4-step process. This has been applied outside the context of combat operations as well. So I'll talk about what each of these steps are just real briefly. And the first step of the Hoodaloo is observation. Observation involves taking in information from sensors, from computers, from your physical sensors, your vision, your hearing, and bringing all of that in. The second step is to orient. Figure out, what does all this information mean? What's the most critical information so that you can prioritize that, and you can put it in the context of a mission you're trying to accomplish or an action you're trying to take. And in the fighter part of the scenario, you also have to consider the rules of engagement. Just because you have a good scenario that you think could achieve a good outcome, if it's not something that is really an allowable action, you have to consider that. And then finally, making that decision about this is what I'm going to do, and then taking the time to actually commit to that action. The idea here is that this process takes time. And when it's done by a human, it can take significant time, with the idea that if you're competing in a combat environment, you want to complete that loop before your enemy does, so that you can get inside their action loop in order to have effect. Now, in an offensive scenario, you might successfully close the Hoodaloo and achieve the destruction of your target. There are other effects you may want to have. You may be able to achieve collection of information from an adversary, not necessarily combat, I understand. But from a defensive standpoint, what you're trying to do is, if you are able to close that Hoodaloo loop before your attacker, then you have opportunity to take defensive actions. You can avoid that attack, you can more quickly detect it, and you can take actions to be more survivable, or to mitigate an attack and to recover capabilities. Now, when we talk about maneuver and movement, Army doctrine talks about the concept of achieving a position of relative advantage. Again, in a very tactical sense, what we're talking about is limiting the amount of attack surface, for instance, in a cyber warfare scenario, or being able to detect an action that is about to result in an attack, or at least minimize the impact of an attack. This plays in as one of multiple considerations, but I think in the cyber warfare, or in the context of cyber capabilities, this concept is very new. I think, let me take that back. The concept itself is not new. The concept is ages old, but the way we apply this to defense is fairly new. We haven't really maximized potential in this space. So let's talk about some considerations with maneuver. Going back to multi-domains, when we talk about maneuver on land, a lot of us are familiar with this because we grew up in a terrestrial environment. We know that there are obstacles, we know terrain, we understand how that can benefit us when we're trying to achieve a position of advantage. And of course, we're mostly talking two-dimensional maneuvering. On the sea, you have kind of a similar construct, except you don't have fixed terrain. You have terrain that's constantly in motion, and more importantly, you have a lot more vast amount of space. How much of the Earth is water? It's a lot. And then we talked about submerged warfare. Now, when you're underwater, you introduce another dimension of movement. You've got depth, and you've got different dynamics that take place within that environment that you have to consider. And then finally, of course, you get to air. Well, not finally. One of the final ones there. Again, three-dimensional movement. Different things to consider there. What altitude are you at? What's the temperature? Winds. Each of these environments has different considerations. And then you get into a higher altitude and you end up in space. Space itself, we've got a space force now that can focus on that. Someday we might have a cyber force to do that as well. But the Space Force understands that the difference in the amount of atmosphere there is will physically change the dynamics involved in maneuver. And largely because of the civilian use of space and the impacts to civilian use of space, safety becomes a consideration that maybe doesn't apply as much as it does in other things. And of course, when we talk cyberspace, there's an infinite amount of maneuver space, right? Cyberspace, cyber infrastructure, information technology, it's all a construct that we've developed from scratch. Although there's a caveat. We can't communicate in cyberspace without having some understanding or commonality of ground of how we're going to do that. There are also physical constraints, such as electricity, medium, like cables or RF, those kinds of things. But when I talk about the information piece of this, understanding how we're going to negotiate a standard to achieve communication or a certain type of communication is dependent upon just that, common understandings. While this enables communication, it also enables malicious actions. So we have to understand that someone with malicious intent can take these same constructs and leverage them to their advantage. Now, what does that mean when we talk about maneuver? Well, we seem to be restricted based on the protocols that are given to us in order to communicate, right? Well, not necessarily. All we really need to care about are what are the common standards that apply to a specific scenario within certain infrastructure. If we're communicating between points A and B, we don't necessarily care how the rest of the world is communicating. We care how the infrastructure between those points are communicating. And by the way, those infrastructure points are not necessarily engineered to consider every type of manipulation that you can actually have with that communication. So again, a lot of room for malicious intent, but from a defensive position or defensive mindset, there's a lot of potential there to leverage that flexibility to maneuver in cyberspace in a way that a party that's trying to observe your actions may not be able to anticipate or may not be able to follow. So in other words, you're kind of taking a proactive defensive position by applying some of those exploitation techniques in your everyday communications. Now, it doesn't mean that the threat goes away. So when we talk about types of maneuver in cyberspace, there are some commonalities here between what we can do to maneuver or adjust in perhaps unanticipated ways, and the research and activities that have already been conducted by malicious actors. You know, when they are exfilling information, they're using activities such as side channel attacks, where they're observing not necessarily the direct communication, but observing physical characteristics that give cues about the communication so that they can then interpret that and do something about it. With covert communication channels, they're leveraging deliberate communication capabilities, but in a way that's unexpected or perhaps bypasses sensors that are in place to help protect against that. Modifying communication paths, such as the use of a virtual private network, are ways to adjust how you're doing that communication in a way that minimizes that attack surface and also gives some level of protection. And then using ephemeral, or in other words, temporary kinds of descriptors, and compute resources also provides some maneuver because you're not in a persistent constant environment that facilitates the cyber kill chain. Those of you familiar with the cyber kill chain understand that in order to target a computer or device on the internet, you need to first do some reconnaissance, understand what it is, how it's configured, what its vulnerabilities may be. And so that's the beginning of the adversary's Hoodaloo, where they're doing that observation. Well, if you can modify any traits that are exposed, that observability factor, then by the time they get around to orienting, deciding, and acting, you could have already moved on to a different configuration, which then kind of resets their whole targeting cycle. So that's the idea behind leveraging some things that are already being researched and created for the purpose of efficiency, but applying them in a way that creates a more defensible position that can help avoid attacks proactively. And then finally, what I want to discuss is binary deception. Deception is a loaded term. Military deception has been around for a long time. There's a past military cyber affairs article on it, which I recommend. But when we talk about military deception, the idea there is to kind of mislead an enemy into thinking thinking that you're taking an action that you aren't, or into covering up an action that you are taking. In the area of cyber warfare or offensive defensive cyber, this kind of often comes in the form of malware. Malware authors understand that defenses that are put in place to detect and mitigate malware are often based on static descriptions, or they're not able to necessarily react to changes in behavior. They're very focused on what does something look like. So the answer to that is to change the way it looks. So malware authors have gotten really good at obfuscating the way things look, or coming out with new variations that helps and pass with a different kind of approach to make that more difficult to defend against. And then when we talk about network communications, there's a plethora of different kinds of actions that can be taken against, or proactively taken to adjust the way that the network packets can be observed. That can be done through a different use of timing. Again, keeping within the constraints of the expected infrastructure, leveraging those flexible areas by changing timing or sequencing, or even adjusting the way a packet looks from one protocol to another to mislead devices that are handling that information. So overall, when you talk about maneuver in cyberspace, what you really need to understand is what's your objective. Are you trying to protect against an active adversary? And then understand how that adversary may be observing what it is you're doing before deciding what step you're going to take. And then finally considering the risk. While maneuvering does provide some benefit, it's not the ultimate defense necessarily. It's a defense that is used in conjunction with other defensive actions, but it can provide a positional advantage. And then finally, talk about some use cases. So why is cyber maneuvering important? Well, we've seen that protecting information through the use of encryption is useful, but it doesn't necessarily remove the opportunity for an enemy to observe data that's being transmitted. So you can use cyber maneuver to make it more difficult to fix on a particular communication. That can be helpful not only for protecting the data within, for instance, the network packet, but also protecting the point of origin or destination of that communication overall. And again, if you're taking action in an area where there's an active adversary who's likely got, kind of classic wiretaps and data captures happening, then you can use maneuver to either make it more challenging for them to assemble a complete picture, or perhaps even avoid their detection altogether. And the same thing applies for adversaries. We've heard in the last few years, we've heard that when there's an intrusion, it turns out that initial intrusion occurred months, weeks to months before an actual effect had taken place, such as some type of offensive attack against the system function or data theft. And there are also other attacks that are more instantaneous that aren't necessarily delayed. But in either one of those cases, using a maneuver technique that adjusts your observability can help protect against that. And of course, you can maneuver the last bullet there about threat awareness. My analogy is, if you think someone's following you on the road, you change lanes and see if whoever you think is following you also changes lanes. So it's a way to kind of increase your awareness of any activity out there that may not be friendly. And so those are the main points I wanted to make about it. I also want to point out that there are lots of writings about this. Again, I think it's an opportunity to leverage this capability to increase our defense. There are some groups out there that are working toward that. A lot of research has been done on it. And there are some commercial capabilities out there that can be leveraged for L3Harris does have one of those capabilities that I'm happy to talk about, but there are also there are capabilities that range from, you know, protecting processes on your computer to protecting a network to protecting entire enterprises. The challenge, of course, is how to do that in a synchronous way in a complicated, you know, multi-host environment. But with today's administrative kind of tools, I think we have some capabilities there that we maybe didn't have in the past. All right, that completes my discussion. Do I have any questions or points people want?
So you made the comment about having a box for stealth, and so I think that you were talking about that moving architecture to the cloud and then being able to shift it is one of the solutions we should be looking at.
That is definitely one possible solution, and I wouldn't say just moving it to the cloud, because there are ways to host information in the cloud that may give you information technology advantages, such as not having to maintain things directly, but it doesn't necessarily impact the observability or the defensive profile of your capability. I think more importantly, if you move things to the cloud, you should leverage some of the cloud unique kinds of security capabilities that exist, because in one way you're providing IT advantage, but you may be creating a vulnerability that you didn't have before. So you need to be sure to check into what those security capabilities are, some of which may involve maneuvering, and definitely if you're in a cloud environment, you have some potential there to be able to do things like ephemeral server, VM presence. Okay. Any other questions? Yes.
Just curious, is there any idea what the cost would be, the added cost would be to do something like this, to provide that added layer of, say, consumption or
I'm going to have to refer back to my colleagues. It depends, slide. I think there are definitely complicated ways to do things and more simple ways to do things. But sometimes the simple ways to do things have applications that perhaps aren't anticipated. I will say that one of the more simple ways I've seen of types of applications is, instead of trying to host a capability on multiple machines, perhaps thousands of machines, you host the capability centrally, and you use a central box that could perhaps translate information as it goes in and out. So kind of like an encryption device. It takes data and encodes it so that it can be decrypted or observed. You can have a similar device in a similar location that rearranges data in a different way, not necessarily encrypt it, but changes those observability factors. And again, because it's a virtual space, how you do that are numerous, ways to do that. So I'm happy to have further discussion on that. I do hope to put together a paper and put it in the journal one of these days. I do have an article in the magazine, though, if you're interested. It's a little bit about extraordinary. All right, well, thank you.